So in order to maximize the efficiency of this system, I am going to incorporate the multi-programming operations. In few of the cases, operating systems are placed at the last memory location of the main memory. You will get at least one question for 8 marks. That is sure. Hello everyone, it is Dr. Ravi Kumar YB, Department of Computer Science, Vidhyaashram, First Grade College, MYSURU, the Temple of Excellence. In today's session, you will learn about the operating system. The Unit 3 of System Software and Operating System subject includes the operating system. In the previous session, you have learnt about what is an operating system and how these operating systems are helpful in interacting with the hardware devices of a computer. If that is the case, let me tell you as to how we can define the other types of operating systems. That is, the word other types of operating systems includes multi-programmed environment. What is the meaning of multi-programmed environment? At the same time, we can perform multiple processing operations. That is called as parallel processing operation. But in this case, I am using the word multi-programming environment. Let me take you into the details of that. Here, multi-programmed system indicates that to overcome the drawbacks of underutilization or the problems of underutilization of CPU and main memory, the multi-programming was introduced. What is the meaning of underutilization of CPU? Let me explain you with an example. I have a CPU here, within which you will also have memory, within which you will also have some of the I/O device, processor, that is actually the processor which performs the task of I/O devices. All these I/O devices are connected to CPU. That is, these I/O devices are connected to CPU. Now, if I utilize the time for performing the CPU operations, that is either memory operations or I/O device operations, or I'm using the word or, this indicates that if I completely use the memory operations and leave this I/O operations blank, and if I fully utilize this memory operations, the I/O devices will become vacant. Similarly, if I utilize completely the I/O operations in the second case, case 2, if I completely utilize I/O operations, processing operations, and leaves CPU operations blank, this condition is called as underutilization of CPU. That means it is almost blank. This is called as an underutilization of CPU. we have this term here. So in order to maximize the efficiency of this system, I am going to incorporate the multi-programming operations, because an interleaved execution of multiple jobs by the same computer helps the system to improve the efficiency of it. What does that mean? If there is a balance of IO operations and memory operations, that is, a mix of these terms makes the system efficient. By doing this multi-programming environment, by making the system multi-programming, it makes the system balanced and efficient. That is the term I'm going to use here. Because in multi-programming system, when one program is waiting for IO transfer, that is, as I told right now, there is another program ready to utilize the CPU. So it is possible for several jobs to share the time of the CPU, that is cycles per second, that is CPS, is going to be shared among multiple jobs at the same time, so that there would not be any free time. Any of the devices will not be left blank at any sort of time or at any point of time. That is the reason I am saying that multi-programming. If there is any device or processor left blank, that is called as an underutilization. Suppose if I completely do the CPU operations and leave the IO operations, then it is called as overutilization. Because one of the process is already executing and another process is waiting in queue for making the use of this CPU operation. This is called as overutilization. Instead of that, suppose if the second process wants to perform the IO operation, let this do the second operation, that is the IO operation. In the meantime, let the first job complete the CPU operation. Once when the CPU operation is completed, suppose if there is any use of IO operation for job 1, let it make use of the second operation, that is IO operation, and the second job which is waiting for the operation of CPU can make use of it at the same time. So we are going to perform the multiple programming operations, that is called as multi-programming environment. That is what I am going to convey now. But it is important to note that multi-programming is not defined to be the execution of jobs at the same instance of time. It is important to notice that multi-programming is not defined to be the execution of jobs at the same time. That means execution of same job at the same time. Is not possible at all. Rather, it does mean that there are a number of jobs available to the CPU placed in main memory. Number of jobs available in the main memory already. And a portion of one is executed, then a segment of another, and so on. That means if there is any one of the program is executed completely, there is a chance for another program which is waiting in queue for execution of those in CPU. That is the utilization of CPU. A simple process of multi-programming is shown in the figure. You will see in the next slide. That is this. I have a job 1 here, job 2, job 1, job 2, job 3, so on up to job n. This is the operating system. In few of the cases, operating systems are placed at the last memory location of the main memory. And in some of the cases, in some of the systems, operating systems are placed at the beginning of this, and rest of the jobs are placed in the next and subsequent locations. That depends on the architecture which they design for the system. In this case, the operating system is placed at the end of the memory, main memory or RAM. Now I have a memory here. Now a program in execution is called as a process. As you all know that the program is executed, the time at which the program is in execution is called a process. The job or a task, I will call it as a task. The concurrent execution of programs improves the utilization of system resources and enhances the system throughput as compared to batch and serial processing. If that is the case, in this case, when a process requests some I/O to allocate, meanwhile, the CPU time is assigned to another ready process. So, here when a process is switched to an I/O operation, the CPU is not set idle. That means when the process is switches to an I/O operation, the CPU is not kept idle, because the utilization of CPU can be made available for another process which is waiting for the CPU operation, so that the two processes are executed at the same time. But what is that I stated in the notice? Execution of same job at the same time is not possible. But in this case, what I am telling now, the CPU is not kept idle so that the other processes which are waiting in queue wants to use that CPU can make use of that CPU operations. That is possible. In case of multi-programming environment, multi-programming is a common approach to resource management. That is, the essential components of a single user operating system includes a command processor, an input or output control system, a file system, and a transient area. That is called as multi-programming environment. What is the meaning of, I'm using one more term here, transient area. What is the meaning of transient area? The area which is used for swapping the operations of it. That is, when I have one of the job here and I have one more jobs to be done, I will keep few of the jobs in my secondary memory. If this job is executed completely, I will swap this to this area and this is to this area. And at the same time, I have reserved some memory location to this operating system, that is called as transient area. Because this area is reserved for operating system in few of the operating system, in few of the system architecture. In few of the system architecture, the beginning of the main memory is reserved for operating system, that is called as transient area. That is not at all used by any of the jobs. In this case, when a job needs to execute, that can swap into another location, and these jobs which are waiting in queue in secondary memory can be brought back to this location and executed. But at any point of time, it cannot use, that is either job 1, job 2, job 3 or job n into the location of operating system. Please keep this in your mind. A multi-programming operating system builds on this basis, that is subdividing the transient area to hold several independent programs and adding resource management routines to the operating system's basic functions. Please understand that I told you that the operating system is placed at the beginning or at the end of the RAM, that is random access memory. In this case, suppose if there is any information which needs to be executed, that is the program needs to be executed, then they hold several independent programs, and adding resource management routines to the operating system is done. That is the concept of that. Then we will move on to the next important type of systems, that is time sharing system. In my previous session, I also gave you the information about the time sharing system. What is the meaning of time sharing system? The round robin CPU scheduling algorithm, also called as RR-CPU scheduling algorithm. Suppose if there is a time slot of 10 seconds, first 2 seconds are allotted to one of the job, that is job 1. Next 2 seconds is allotted to job 2. Then next 2 seconds are allotted to job 3. So the multiple jobs are using this time, that is 2 seconds are utilized for job 1. Soon after the completion of job 1, it is not yet completed fully, that is the job 1 is not yet completed. However, we will leave the time for the next job, that is job 2, for 2 seconds. Again, after the time of 2 seconds, we will give the time, that is CPS, cycles per second, to the third job, that is job 3. Once when the 2 second is over, we will come back to the first job and this job 1 is executed for next 2 more seconds. There may be a possibility of completing the 2 plus 2 is equal to 4 seconds are sufficient enough to complete job 1, then this completes. Again, I have 2, 4, 6, 8, one more job, that is job 2, which is already completed its task. Suppose if the job 2 is already completed in the first round, then there is no need to go and execute the job 2 once again. It directly switches over to the job 3, which requires 2 more seconds. That is, a total of 10 seconds are needed. So job 3 is allocated with 2 more seconds. So 2 plus 2 is equal to 4 seconds are dedicated to job 3. Four seconds are dedicated to job 1. So 2 seconds are dedicated to job 2. So if that is the case, a total of 10 seconds are there. So these 10 seconds can be utilized for all the execution of these jobs, that is job 1, job 2 and job 3. If that is the case, the time sharing, I am sharing the time with all these jobs. That is the definition of that. That is, a time sharing system allows many users to share the computer resources simultaneously. In other words, time sharing refers to the allocation of computer resources in time slots to several programs simultaneously. That is job 1, job 2, job 3. For example, a mainframe computer that has many users logged on to it. Each user uses the resources of the mainframe, that is memory and CPU. Suppose if multiple user tries to make use of the resources of the system simultaneously, then it is possible to make use of it in terms of time sharing. That is, 2 seconds may be allotted to one of the user, next 2 seconds may be allotted to the second user, next 2 seconds is allotted to third user. I am not speaking in terms of the resources, I am speaking in terms of time now, because time is very, very important, because the efficiency of a system or the performance of a system is measured in terms of time as well. That is the reason I am considering the time sharing system as very, very important in hybrid computers or in supercomputers, wherein if they want to do certain operations, that has to be done within a stipulated time. That is why the time is shared among multiple users. The time is shared among multiple jobs or multiple tasks or multiple programs or multiple processes. That is the reason I am calling this as a time sharing system must be very efficient, which increases the performance of a system, similar to the multi-programming system. So if that is the case, if users feel that they are exclusive user of the CPU, even though this is not possible with one CPU shared among different users. I am using the word exclusive user. Suppose user 1 is there, user 2 is there, user 3 is there. Exclusively user 1 wants CPU utilization. User 2 and user 3 wants CPU as well as memory utilization. So we need both CPU as well as memory utilization to be completed for this user 2 and user 1. This person, that is user 1, wants only exclusively or only CPU utilization. That is the reason I am calling this as the word exclusive. So the time sharing systems were developed to provide interactive use of the computer system. A time-shared system uses CPU scheduling and multi-programming to provide each user with a small portion of a time-shared computer. As I have already discussed in the previous slide, that is, this time is shared among multiple jobs or multiple users. That is, this time-sharing system allows many users to share the computer resources simultaneously, the same thing. As the system switches rapidly from one user to other user, the slot is given to each user for their execution. Let me take you into this now. What is the meaning of this? Suppose user 1 wants to use the system for 5 seconds and user 2 wants to use the system for 3 seconds. User 3 wants to use the system for 5 seconds. So totally, if there is a time quantum of 3 seconds for each of these systems, then what happens? 3 seconds are dedicated to this and the remaining 2 seconds are needed to execute the same program. But it has to be switched over to the next job which requires 3 seconds because I have a time quantum of only 3 seconds. So I can execute or provide a time of 3 seconds to this user. Once when this is completed, it has to switch to the next user, that is user 2, who require 3 seconds. While switching from the time required to switch over from user 1 to user 2, that is called as slack time. The same thing is explained here. Switches rapidly from one user to other, a short time is given to each user for their execution. That means a slack time is required to switch over from one of the user to another user or from this user to this user. So the slack time, the time which is dedicated for switching over also matters in case of time sharing system, because the time which elapses once while switching from one of the user to next user and this user to this user, that is also counted as a performance matter. Next, the time sharing system provides the direct access to a large number of users where CPU time is divided among all the users on scheduled basis. That means all these users are dedicated to certain time, that is 5 seconds, 3 seconds, 5 seconds are the time dedicated. But what is the time quantum allotted to them? 3 seconds for user 1, 3 seconds for user 2, 3 seconds for user 3. This is called as a time quantum, which you are going to learn when I start explaining about the problems of CPU scheduling algorithm and the disk scheduling algorithm. Let me have the word here, CPU scheduling algorithm. Dear students, please make a note of it. You will get at least one problem in the examination. This is very, very important. Please note this. You will get at least one question for 8 marks. That is sure, 100% sure. You will get this question. The OS allocates a set of time to each user. When this time is expired, it passes control to the next user on the system. The same thing, the time quantum. When 3 seconds is over, switches over to the next user. Then 3 seconds is over, switches over to the next system. The same thing is explained here. It passes the control to the next user on the system. So let me take you into the next slide. That is, it allows many users to share the computer resources simultaneously. The same thing is explained here. Next, the time allowed is extremely small and the users are given the impression that they each have their own CPU and they are the sole owner of the CPU. That means suppose if there are multiple users, that is user 1, user 2, user 3, user 4, so on up to user n. Suppose if all these users are using this, then each of these users feels that they have their own resources. That is as if they are using the resources individually. That is either CPU or memory is going to be utilized by these systems efficiently. That is the meaning of this. They feel that the resources of the systems are allocated to them. That is the feeling they understand when the time is shared among multiple users. It is multiple users. Then this short period of time during that a user gets attention to this of the CPU is known as time slice or quantum, as I have already explained in the previous slide. Now, if you look at this diagram, you will say that the CPU is at serving the service of user 5. Next, after the time quantum expires, move to the next this operation and services user 6. Once when the time quantum expires, moves to this user 1 and services the request of user 1, then user 2, then user 3, then user 4, comes back to the same user, that is user 5. So that each of these users will experience the use of all these resources at the same time simultaneously. They feel that the resources are dedicated only to those individual users. That is the feel and experience they experiences in case of this time sharing system. Yeah, in the above figure, user 5 is active, but user 2, 1, 2, 3 and 4 are waiting state, whereas user 6 is in ready state. What does that mean? Let me have one more information for you now, that is this new, ready, running, waiting, altered are the states of processes. Which I am going to explain in the next and subsequent classes. Let me not go into the details of these states now. That is state 1, state 2, state 3, state 4, state 5. Because which is in queue, which is the next process which is in queue? User, that is user 6. So it must be ready when the process comes to this user. Because the other users needs to wait for some time. So I will call that they are in waiting state. Which user is ready now? 6th user is ready. So user 6 is in ready state. Which user is using this state? The running. It is in 3rd state. That is running state. CPU is in running state. As soon as the time slice of user 5 is completed, the control moves on to the next user, that is user 6. As I already explained to you, when the time slice or quantum expires, moves to the next user and the control of CPU is given to user 6. The same thing is explained here. In this stage, user 2, user 3, user 4, user 5 are in waiting state and user 1 is in ready state. Process continues in the same way and so on. The time-shared systems are more complex than the multi-programming systems. The time-shared systems are more complex than multi-programming system. And of course, because it has to switch over from one user to another user and from one job to another job. So it is very much complex. So let me take you into the details information. That is, in time-shared systems, multiple processes are managed simultaneously, which requires an adequate management of main memory so that the processes can be swapped in and swapped out within a short time. As I have already told you that the list of jobs waiting in the main memory needs to be swapped to the secondary memory, and needs to be swapped into this main memory. That is, swapped out and swapped in is possible in case of time sharing system. So again, a slack time is needed to swap out the process into the secondary memory and swap in this required process into the main memory. That is called as a slack time. That is also considered for the estimation of performance of a system. So notice that, please note that once again, one more important point. That is, the time sharing is no longer commonly used. It has been replaced by multitasking system because it is very much complex, and the performance of a system also sometimes comes down. So that is the reason we have multitasking system. What is the meaning of multitasking system? Multiple jobs are going to be done at the same time. That is the reason we are having the multitasking system, that is called as parallel processing system, parallel architecture. We will have dual core architecture system. We have quad core operating system. We have octa core architectured systems. What does the requirement of that? What is the requirement of those architectures? Quad core, octa core, dual core, single core. What is the use of all those things? To carry out the multiple tasks at the same time, so that the programs or users' requests are executed or serviced respectively appropriately. That is the reason we are considering this multitasking environment, which I am going to explain in the next session. Dear students, kindly come back to me for the live session if you have any doubts or questions with respect to the concepts I discussed in today's session. Thank you very much. Thank you one and all.